So now that we have some tools for tackling integrals, we're going to consider a useful specific application of them. So that application is averages, which is an idea you're super familiar with. This is baby math, right? So 4 tiers, 2 tiers, and 6 tiers. And then we want the average number of tiers. Well, it would be 4 plus 2 plus 6 over the total number of values, which is 3. So I get 12 over 3, which is 4 tiers. Right. So that is the notion of an average. Notice, so that's very discrete and oversimplified, and often when we measure things in real life, they're a little bit more complicated than that, right? So say instead of having just a nice number of tiers, we have this pretty ugly function here, f of x, to represent our number of tiers. Our question is the same. On average, how many tiers are on your face over the first 8 minutes? And then I gave you a graph of f of x, and notice we start with like a little about 6 tiers on our face, and then we peak at higher than 8, and then eventually we get down to 0 tiers, and then we go back up a little bit again. So true emotional roller coaster calculus is. This is a harder problem because it's one continuous curve and it fluctuates, right? So I might consider eyeballing it. It might be like, okay, well, my average value is probably somewhere right around here, because then I have about half of the function above it, half of the function below it. I could guess, but up until now, we didn't have a tool to figure this out. Because think about what this is asking us to do, right? It's like every x value to take an average, I'd have to add them all up, right? And then divide by the number of values that we have. Well, the problem, right, is that if it's a continuous function, there's an infinite number of x values to add up. And so I can't necessarily use my baby idea of an average, but really what we mean by adding up all of the x values is just the area under the curve. So I can take, in this case, the total area under the function f, and then divide by the width of the interval. Width of the interval is just all the way from 0 to 8. So we already have notation for this, right? It would be something like this. The integral from a to b of f of x dx. And then divided by, I'm going to write it as a fraction out front because it's easier to write it this way, but divided by the difference between a and b. Okay? This integral represents the average value of a function, and it makes sense that it would, right? Because it really is directly in line with our kind of baby notion of an average up here, just written in terms of this new calculus idea we're studying. So in this particular case, it would be 1 over 8 minus 0 times the integral from 0 to 8 of f of x dx. And then at this point in the game, I would use a calculator to evaluate that. So I typed in my whole function. I used the fraction bar to get the 1 over 8 minus 0, integral from 0 to 8, and then f of x is exactly how it appears, dx. And then I hit enter, and calculator thinks pretty hard for this one, and I get about 3.427. And then I can write a noun unit time for this, right? So I can say something like from 0 to 8 minutes, the average number of tiers, so f is the number of tiers, right, was 3.427 tiers. And that's it. And notice my units just match f, which makes sense, right? Because we're writing an average value of f. If f is tiers, the average value of f would be also tiers. So this is not so hard, given the work we've done on integrals already. But whenever I've taught this, I've always noticed that students get this average value confused with another average that we've taken before. So I've gone ahead and typed in that expression we're considering carefully, right? So I typed in the whole function, plugging in 8 for x, that's f of 8, and then minus f of 0, so replace x with 0, and then divided by 8 minus 0. And that gets me negative 0.360 for that expression. And we should know what this means already. It's negative 3.60 tears per minute. Our interpretation would be that the number of tears decreased by 0.360 tears per minute on average from t equals 0 minutes to t equals 8 minutes. So this is, of course, an average rate of change. We could also use it to estimate a derivative if we were asked to do that. But we get confused by this because this says average, this of course says average. So the way we're going to fix that problem is we're going to work on these together. So we're practicing the new integration skill and recognizing which type of problem is which. The last thing we are going to do here is just note that I can estimate averages using Riemann sums as well. So notice we have an average value integral here. So 1 over 10 is 10 minus 0, and then the integral from 0 to 10 dt. But then it gives me a table and asks me to use a Riemann sum. Now, I'm not going to solve this live in the video, but I'm going to put up the solution to this and the interpretation so you can check your work. It would be a smart thing to pause and solve this one for the practice and then check against mine. The thing you want to focus on is making sure you understand the interpretation that I write as well. So here's my solution, 40.2, and my units are going to be gallons because gallons is in the text. And then my noun unit time interpretation, my time is from t equals 0 to 10. My noun is the average amount of water in the tank because we started with water in the tank. And I'm going to throw in this word approximately because I estimated using a Riemann sum was approximately 40.2 gallons. And that is it. So we're doing several things here: average value, average rate of change, and some problems involving estimates from tables.